Okay, let's move on to the to chapter number 2, structure of atom. Until 1808, when Dalton proposed Dalton's atomic theory, which was based on the assumption that the matter contains all the matters around us is made up of atoms of different elements, and atoms cannot be further divided. It is indivisible. And that theory was very successful because it can prove the law of conservation of mass, the law of definite proportion, and law of multiple proportion. But that theory of atoms, which was not visible at that time, could not explain certain observations, like when we rub ebonite or glass with the fur, the, how they attracted the papers, or how they attracted or repelled the papers. That could not be explained. So basically, the formation of charge by matter, maybe positively or negative charge, because of which matter attract or repel when they get electrically charged, could not be explained by considering that matter is made up of atoms which are indivisible. So later on in the late 19th century or early 20th century, there was a there were experiments were conducted which proved that atoms contains subatomic particles. Atoms can further be subdivided. It contains smaller particles in it, or subatomic particles in it, like electrons, protons, or neutrons. So one of the important experiments which led to the discovery of electrons or negatively charged particle which might be present inside the atom is this the cathode ray discharge tube, cathode ray discharge tube experiment. Although in 1830 Michael Faraday observed that electric current can pass through electrolytes, and the deposition of and because of that chemical reactions take place inside an electrolyte, an aqueous solution of a salt, and there was deposition of metals on the electrode. So like in electrolyte, which is a salt solution, electric current passes through the salt solution. So in the same line, an experiment was designed in late 50s, in 1850s, called a cathode ray discharge tube experiment. So what is a cathode ray discharge tube? So there's a tube, a glass tube was taken, and it contained a thin metal plates, and it was designed in such a way to okay, the two thin metal plates are called electrodes, and they were connected to a very high voltage. The very high voltage were applied across the electrode. So these are metals, and the in order to and the pressure of the gas, whichever gas that was inside the glass tube, was maintained. It was generally reduced by pumping it through vacuum pump. Using a vacuum pump, the gas was removed so that the pressure inside the tube is lowered. So what we found was that when we applied a very high voltage, and the pressure of the gas inside the tube is reduced drastically, that means at a very low pressure, we find that something came out from this, and we find that this electric uh, this discharge there was a discharge of electricity through it. And electricity, this tube conducted electricity. Somehow, see, there is nothing inside it, although there was a gas in it, and it started conducting electricity. There was a discharge of a ray from the cathode. And what is cathode? Cathode is the electrode which is joined to the negative terminal of the battery, a source of high voltage. So it is negative. It is a terminal which is joined to the negative terminal of the battery, and this one is anode, which is joined to the positive terminal of the battery, supplying high voltage. So something got emitted from here which was not visible, and which strike the and when it was made perforated, the anode was made perforated. Many holes were made, and we find, and one fluorescent coating was made at the end of the tube. It glue. It was made of a zinc sulfide, and it glows. So there was something that was emitted from this, from the cathode, but in which traveled straight, and when it hit the fluorescent coating, it glowed. So let's sum up what was the result of this experiment. What we find was that uh, cathode rays, they got emitted not from the anode, from the cathode. And what is from the cathode electrode, the one which is joined to the negative terminal of the battery, right? And it was emitted from the cathode, and it traveled towards the anode, although it was not visible. Second point is that the cathode rays were not visible. They were so small that they were not visible to us. But yes, it is true that when they were meant to travel through the anode, well, after perforating, it hit the glass test tube, which was coated with fluorescent, and it glue. So it glue means what? It was proof that it's traveling in straight line, and it has some charged particles, because of which it glows. The fluorescent glows, because fluorescent glows only when some charged particle hits it. Fine. Now, if we do not apply any electric field over this, over the cathode ray tube, that means in the absence of electric field and magnetic field, the charged particles which are emitted from cathode, they travel in straight line. Fine. And when electric field and magnetic field were applied, they behave as if they are negatively charged. This is point number 4. And no matter what kind of gas is present in, and if we change the kind of electrode, it may be a gold or platinum or any other metal, we find that the characteristics of the charged particle does not depend on the kind of electrode that you are taking, or the kind of gases that with which the cathode ray tube is filled up. So that means something which is coming out from this is universal. It contains in all the metals, or it contains in the gas that is it's something which is universal. Since it is coming out from here, no matter what the matter is, or no matter what the metal is, it is present in them also. So the characteristics of the cathode rays were independent. They will later be called as electrons, right? And they are independent of the kind of electrodes that you have taken.